All attendees are in listen-only mode.
Hello and welcome everybody to today's webinar, National Electrical Code On-Site Power Generation and Distribution Part 2. My name is Frank and I'll be the moderator for the day. We'll be starting shortly, but before we begin, I'd just like to remind everyone that it's extremely important to be logged into the webinar on your own device using the specific link that was sent to your email. The link that was sent to your email is specific to your name, so by using your own device and login, Half Moon Education may verify your attendance in the event that Half Moon or you are audited by any licensing board. If you are sharing a computer, listening in with someone, or for whatever reason are not logged in on your own connection for the duration of the webinar, you will not have access to the follow-up quiz or to the CE certification download. So if you are not already, please log on your own device right now. Second, to the right of your screen, you'll see a panel. Towards the bottom of this panel, you'll see a dark gray questions bar. If you double click this questions bar, it will open and allow you to submit any questions you may have during the webinar. Please feel free to ask any questions at any time, and we will be answering them as soon as we can. This includes any questions you may have for me. Next, if you still need the slides for today's PowerPoint, the PDF file can be found under the gray Handouts tab, which is located directly underneath the Questions tab. Lastly, should you lose sound through your computer speakers, please see the Audio tab in the panel. You'll have the option to dial into the webinar with your phone. For any other issues that may arise, please call Half Moon's customer service at 715-835-5900. With that being said, I'll turn it over to our speaker, Mr. J.R. Cromer.
All right, guys, welcome back. This is an overview of the whole National Electric Code, and we're still stuck in the beginning sections. So, to get through in a timely manner, what we're going to do is try and go as quickly as we can through the kind of remaining general section over the first half of today. And then, regardless of where we're at in the second half, we'll skip into the later sections, the solar specific sections. But I think it is worth poring over the early sections in code because it lays the groundwork for the special sections that are yet to come. For instance, here in 230, we're talking about service entrance conductors, not just feeders, but a specific kind of feeder, just the services supplying the whole building. And it says, in the raceways of service conductors, other conductors are not allowed except for grounds and other kinds of devices that have to do with load management and load control. Which is there's a common kind of question is, are you allowed in solar to have the AC and the DC share the same raceway or or electrical box? And the answer is yes, but you can't share it with other things. But then you might find a situation where, okay, well, I'm doing this solar battery and I also want to power up the weather monitoring station. Do I have to keep that outside the gutter that I'm putting all this cable into? The answer is no. Code does give a little bit of allowance for kind of other devices related to energy management and control circuits associated with energy management. So what they don't want you to do is share the same conduit with your solar circuit and then put in a branch circuit in the same conduit. They want to keep the services separate. And then we see yet again a qualification for a raceway seal. Let's see here. Hold on, let me pull in my backup copy. There we go. All right, so we have the ungrounded service conductors, not smaller than number 8, which is pretty small to begin with, but I guess if you're doing very small service panels, that might give you a minimum size of powering a panel. Protection from damage where entering a they kind of punt that to just slightly later. Splice conductors, they say, hey, we're going to talk about splicing and wiring methods a little bit later in the general section. So we're going to bump into that. And then it says how many service entrance conductor sets, and there's, generally you're supplying your buildings with non-parallel service entrance conductors, with exceptions given to large, like multifamily housing. Let's see. The sizing limitations, again, this is a common thing when sizing wire. It's 125% of a continuous load or 100% of a non-continuous load. And so when you're thinking about upsizing wires on the quiz, you think about, is it a continuous load or not? And then there's an exception that says, well, you can size the service conductors to be 100% of the listing, if they're operating at 100% of their rating. And I think what is lost in my non-direct transcription of NEC is but no more than that. And what I mean by that is, like, in solar we have digital control boxes that we can put behind every solar panel on the rooftop to automatically, that are listed to automatically regulate the amperage and voltage coming out the panel without and if they fail, to kill the power at that point. And that can exempt you from upsizing your DC cable ampacity by an additional 25%, because you are employing active current control on the panel because of these small little boxes. So, sometimes there are exceptions to upsizing, but the general rule of thumb throughout code is 125% for continuous loads and 100% for non-continuous loads. The minimum ampacity for ungrounded conductors, those are the conductors carrying the power into the property, shall not be less than the rating of the service disconnecting means. I find this to be a very encouraging snippet of code, because what it means is that if you have a 200 amp service panel with a 200 amp breaker, the minimum ampacity of the cables going into that service shall not be rated for less than 200 amps. And why I think that's so encouraging is it tells me that, if I turn on all the electrical load in my house, and the current rises to above 200 amps because I have 300 amps of breakers on my panel. If I were to draw all of that amperage through the panel, the breaker would trip before the utility conductors coming into the building start to heat up and smolder. So that's what that is saying. The ampacity of the service conductors has to be larger than the ampacity of the breaker for service entrance conductors. And what we start to see as we get into code is when we get into small breaker sizes, 15 amps, 20 amps, 30 amps, you're taking the amperage and then you're rounding up to the nearest breaker size. When you get into larger conductors and larger cables, you're taking the size of that, the maximum ampacity of that cable, and then rounding down to the next lowest breaker size, so that the breaker protects those panels. So once you get into like 800 amp circuits, 1200 amp circuits, the fuse protection actually throttles the electricity, whereas at the small level, you would put like an 8 amp or 10 amp circuit on a 15 amp breaker, because if you put it on a 10 amp breaker, then the breaker would trip when the device was in motion and the device wouldn't work. I wonder if it's going to be that slow switching slides. so, I'll just pull a, yeah, weird. Huh. Let me pull that another a backup press.
JR, I think we may have lost you a little bit. I can't hear you. I'm not sure if the attendees are able to hear you. If any attendees are having issues hearing